Why do we have to pat test? Welcome to this first stop safety video. This video module will outline why we have to undertake portable appliance testing, or pat testing as it is normally called, and the reasons why this is important. Much in the same way as you would look to check the safety of your vehicle with an MOT test, pat testing involves checking the safety of electrical appliances. Electrical appliances start off perfectly safe, but through use and general wear and tear, appliances can develop faults. They will need various safety checks to reduce the risk of an electric shock or of a fire breaking out. Regular use of electrical appliances can lead to damage. In time, it is likely that the cable could start pulling out of the plug, as seen here in this example, or the wire could start fraying and become exposed, as you can see in this example. When you're fitting or replacing a fuse, it's important to use the right fuse for the appliance to make sure that the cable or appliance does not overheat due to a fault. In some instances, fuses are replaced with tinfoil or with a piece of metal. In this case, if the appliance was to develop a fault, the cable and the appliance are at risk of overheating and causing a fire. Increasingly, insurance companies are specifying the need for pat testing as a necessary condition of insuring a property. The Electricity at Work regulations covers everything from the wiring in the building to the electrical appliances that we use on a daily basis. This regulation highlights the importance of inspection and maintenance of electrical equipment in the workplace. The EU Low Voltage Directive governs the manufacture or importation of electrical appliances into Europe. Compliance to this is indicated by this symbol, the CE mark on the product. This applies to all appliances that are available for sale in Europe. The responsibility lies with the manufacturer or the importer, and adherence to the directive is policed by trading standards. Any used electrical appliance that is offered for resale must comply with the requirements of this directive. In summary, portable appliance testing is a legal requirement, reduces the risk of fires, and prevents users getting an electric shock. Wiring a plug. Welcome to this first stop safety video. This video module will give you a simple 8-step guide to wiring a plug. A wrongly wired plug can put users at risk and can be the cause of fires. Step 1. Strip off the outer cable. About 4 centimeters of the outer cable needs to be stripped off to expose the inner wires. A small pair of cutters can be used to nick the outer insulation without damaging the inner wires. Alternatively, a craft knife or scalpel can be used. Step 2. Prepare the inner wires. The inner wires may be twisted. These need to be separated out with the live, brown, neutral, blue, and the earth, green and yellow. Cut the live and neutral wires down to about 3 centimeters so that they are slightly shorter than the earth wire. Note that if this plug is for a Class 2 appliance, there will be no earth wire present. Step 3. Strip the inner insulation. Either with a small pair of cutters or with wire strippers, take away about 0.5 centimeters of insulation from the inner wires. Twist the strands of wires together neatly. Step 4. Place the wires in the plug. Open the plug and either loosen the cord grip screws or take this out altogether. Insert the cable and place the live, neutral and earth wires in the correct place. Step 5. Complete the wiring. Insert the twisted strands through each terminal and tighten the terminal screws. Check that there are no loose strands and that the insulation reaches right up to the terminal. Step 6. Tighten the cord grip. Tighten the cord grip, making sure that this fastens onto the outer insulation. Step 7. Fit the correct fuse. Check the instructions on the appliance to find out the value of the fuse to be fitted in the plug. If this is not specified, then please consult a competent person. As a general rule of thumb, if the appliance rating is more than 1000 watts, then a 13 amp fuse needs to be fitted. If the appliance power rating is between 700 watts and 1000 watts, then a 5 amp fuse needs to be fitted, and if the appliance power rating is less than 700 watts, then a 3 amp fuse needs to be fitted. If in doubt, please don't guess. Consult someone with appropriate experience in this area. Note that a wrong fuse can result in a fire. Step 8. Fit the plug cover. Make sure that the inner wires are in the right channels and are not going to get trapped between the cover and the body of the plug. Fit the cover and tighten the screw. In summary, by following this simple 8-step guide, you can wire a plug and avoid putting users at risk or causing fires. Checking fuses. Welcome to this First Stop Safety video. In this video module, we show how to check whether the correct fuse is fitted in the plug. We'll look at the function of the fuse and the differences between fuses in moulded and rewirable plugs. The function of a fuse. Fuses are used in circuits to prevent excessive currents flowing under fault conditions and causing a fire. The primary purpose of the fuse is to protect the mains cable and prevent it melting and/or catching fire under fault conditions. The type of fuse used depends on the power of the appliance. To spot the difference between the fuses, each is color-coded for easy identification. A 3 amp fuse is red, a 5 amp is black, and a 13 amp is brown. Fuses in moulded mains plugs. As these plugs are moulded to the cable, the fuse in these can be fixed by the manufacturer. They know what the maximum current is that the cable can carry, and the fuse is selected to protect the cable and blow if the current exceeds the capacity of the cable. The value of the fuse that is fitted is marked on the outside. All you have to do is to check that the fuse fitted is the same or lower than that marked on the plug. Here the moulded plug has to be fitted with a 3 amp fuse, as this is what is moulded on the plug. Fuses in rewirable mains plugs. These are plugs which the user can wire. Rewirable plugs have 13 amps marked, as they can handle a maximum of 13 amps. Many people assume that this means a 13 amp fuse should be used in this appliance, but this is not the case. The person inspecting the appliance has to work out the value of the correct fuse. If a plug is fitted with a 3 amp or 5 amp fuse, then there is no need to change it. There is very little risk of fire. If a plug is fitted with a 13 amp fuse, then you need to find out what the power consumption of the appliance is. This is usually indicated in watts on the rating plate. If the power is greater than 700 watts, then leave the 13 amp fuse in place. If the power is less than 700 watts, then change the fuse to a 3 amp one. This is shown on the following diagram. Never change a fuse on a working appliance from a lower one to a higher one. We'll now look at some examples to establish the correct value of fuse to use. Example 1. Iron. An iron is fitted with a 13 amp fuse and the power consumption of the appliance is 1900 watts as seen here. This is greater than 700 watts. The 13 amp fuse is the correct fuse for the appliance. Example 2. Lamp. The advice on the rating plate of this lamp says that the maximum bulb that can be fitted is a 40 watt one. The plug, however, is fitted with a 13 amp fuse. As the power rating is less than 700 watts, we can quickly see that the fuse is too high and has to be changed to a 3 amp one. Example 3. Sandwich toaster. This sandwich toaster has a plug fitted with a 13 amp fuse and, according to its rating plate, has a power consumption of 700 watts. As this is right on the decision threshold, what should we do? In general, heating appliances are fitted with a 13 amp fuse and this can be left in place. Example 4. Drill. This drill has a power rating of 570 watts and is fitted with a 5 amp fuse. Remember, if the fuse fitted is 3 amp or 5 amp, do not change it. There's no need for any action with this. Fuse labels. Once a plug has been checked for the correct value of fuse, it's good practice to seal the plug. If on future inspection this seal is intact, then this is a good indication that no one has tampered with the wiring or changed the fuse. This will save considerable time during subsequent inspections. In summary, fuses protect cables and appliances from overheating and causing a fire. If a 3 amp or a 5 amp fuse is fitted, then these can be left in place. If a 13 amp fuse is fitted, then check the power rating of the appliance to see if this is correct. Main causes of electrical fires. Welcome to this first stop safety video. This video module will run through the main causes of electrical fires and how these can be prevented. Fuse in plug replaced by nail. This is done by some workmen when a fuse is blown and another one is not readily available. The intention is to replace this as soon as they get hold of one, but instead is forgotten about. If there was a fault with the appliance, the plug will overheat and may cause a fire. This type of fault would be picked up during a formal visual inspection. Too high a fuse in plug. Most plugs are sold with a 13 amp fuse fitted. When a faulty plug is replaced with a new one, often the 13 amp fuse is left in without a check to see if such a high value is required. If there was a fault with this appliance, there is a risk of the cable overheating and setting fire to flammable substances close by. This type of fault would be picked up during a formal visual inspection. Loose terminal screws in a plug. When wiring or inspecting a plug, it is important to check that all 3 terminal screws are tight. If any of these are loose, this will lead to overheating and a risk of the plug melting. This type of fault would be picked up during a formal visual inspection. Overloading of extensions. Mains extension leads are normally rated at 13 amp. A 2 kilowatt electric fire takes just over 8 amps of current. If 2 of these fires were plugged into the same extension lead, then a total of 16 amps will be drawn. A 13 amp fuse may not blow until a current of nearly 20 amps is flowing through it. There are extension leads available that are only rated at 5 amps. If a user does not notice this and plugs a 2 kilowatt heater into this, there is a serious risk of fire due to the cable overheating. This type of fault can be prevented with an understanding of amps, kilowatts, and the relationship between the two. Not unwinding coiled extension leads. Coiled extension leads have different ratings from when they are uncoiled. For example, a coiled 5 meter extension lead is rated at 700 watts when coiled and at 2000 watts when uncoiled. If a 2 kilowatt heater is plugged into an extension lead that is still coiled up, there is a risk that it will overheat enough to set fire to flammable substances close to it. This type of fault can be prevented with an understanding of amps, kilowatts, and the relationship between the two. Cables pulling out of appliances. With constant use, some cables on appliances can start to pull out due to the cord grip inside the appliance working loose. This can lead to wires shorting and drawing excessive currents, which can lead to overheating. This type of fault would be picked up during a formal visual inspection. Blocking ventilation slots. Many appliances have ventilation slots to prevent them overheating. They depend on a flow of air to take away excess heat generated within the appliance. If these are blocked, then there is a risk of overheating, resulting in a fire. Early signs of overheating can be spotted by users if they have been shown what to look for. Combustible substances close to electrical appliances. If appliances, cables or plugs overheat due to the many reasons given already, a fire may still not break out. A fuse could eventually blow. However, if there are combustible substances close to overheating plugs and cables, then the risk of fire is a lot higher. Make sure that cardboard packaging or clothing is not stored close to appliances at risk of overheating. Appliances left on overnight. If a fault develops in an appliance causing it to overheat, then the early warning signs, like a burning smell, are easily detected by users, and the appliance can be disconnected. However, if the appliance is left on overnight, there is a risk of a fault going undetected until it is too late and the appliance has caused a fire. It is good practice not to leave appliances on overnight. In summary, a good user checks and formal visual inspection program will reduce the risk of fire. An understanding of watts and amps are important to prevent overloading extension leads.
A Class 1 appliance is an earthed appliance. Open the plug to determine if the appliance has 3 wires. A Class 2 appliance has no earth wire. Again, open the plug to determine that there are only 2 wires. A double insulated appliance is marked with this symbol and must be tested in the same way as a Class 2 appliance.
Pat testing using a BAT-PAT. Welcome to this first stop safety video. This video module shows how the BAT-PAT is used to carry out PAT testing. Testing a Class 1 appliance. Plug the appliance into the BAT-PAT and clip the test lead to a suitable earth point. Make sure that the appliance is switched on. Press the Class 1 button and wait for the BAT-PAT to display the results of the earth continuity and insulation resistance tests. Testing a Class 1 plastic appliance. Plug the appliance into the BAT-PAT. On these appliances, there is no place to clip the earth lead onto, so leave this to one side. Make sure that the appliance is switched on. Press the Class 1 plastic button and wait for the BAT-PAT to display the results of the insulation resistance test. Testing a Class 2 appliance. Plug the appliance into the BAT-PAT. If there is any metal work, clip the test lead onto this. Press the Class 2 button and wait for the BAT-PAT to display the results of the insulation resistance test. Testing an IEC lead. Plug both ends of the IEC lead into the tester and press the power cord button. The BAT-PAT carries out the test and displays the results of the earth continuity, insulation resistance and polarity tests. The polarity test checks the lead is wired correctly. Testing a standard mains extension lead. Plug the mains extension lead into the BAT-PAT. Connect the short IEC lead to the socket of the mains extension back into the PAT tester as shown. Press the power cord button and wait for the BAT-PAT to display the results of the earth continuity, insulation resistance and polarity tests. Testing a long mains extension lead. Plug the mains extension lead into the BAT-PAT. Connect the short IEC lead to the socket of the mains extension back to the PAT tester as shown. Press the long lead button and then press the power cord button and wait for the BAT-PAT to display the results of the earth continuity, insulation resistance and polarity tests. Testing 110 volt appliances. Use the 110 volt adapter to plug a 110 volt appliance into the BAT-PAT. Using this adapter, you can carry out a test on a 110 volt appliance as shown here. Testing a Cloverleaf laptop power cord. Use the adapter shown to connect the Cloverleaf laptop power lead into the BAT-PAT mains socket and IEC socket. Press the power cord button to carry out a full test on this lead. In summary, the BAT-PAT is a simple to use yet versatile PAT tester. It can be used to test a wide variety of appliances.
The earth continuity test is used to verify that there is a good electrical connection between any exposed metal parts and the protective earth pin in the mains plug of a Class 1 appliance. As we can see, the appliance is plugged into the PAT and the test probe is connected to exposed metal parts. Current is then passed from the PAT tester through the protective earth conductor of the mains cord to the enclosure. It then flows back to the PAT tester via the protective earth conductor. The PAT will then display the resistance of the protective earth path. Insulation testing is carried out by plugging the tested appliance into the PAT and applying a test voltage of 500 volts DC to both the live and neutral terminals of the mains plug. If the insulation is in good condition, a high insulation resistance reading is obtained, typically in the order of hundreds of megaohms. If there is a breakdown in insulation between live parts and protective earth, a current will flow across the insulation and back to the PAT via the protective earth conductor. The measured insulation resistance is greatly reduced, indicative of an insulation fault. When testing insulation on a Class 2 appliance, the test probe is connected to any exposed metal parts. If the exposed metal parts are insulated from live parts, a high insulation resistance measurement is obtained. If there is a breakdown in insulation between live parts and any exposed metal parts, a current will flow across the insulation and back to the PAT via the test probe. The measured insulation resistance is greatly reduced, indicative of an insulation fault. To measure a protective conductor current, the appliance is plugged into the PAT. When the appliance is energized, current will flow from the main supply to the appliance in the live conductor, indicated via the brown arrow, and then return to the supply via the neutral conductor. If there is good insulation between live parts and protective earth, the live and neutral currents are equal, i.e., all of the current entering the appliance in the live conductor returns to the supply in the neutral. If there is a fault with the insulation, some of the current flowing in the live conductor will return to the supply via the protective earth. The PAT will detect this imbalance in the live and neutral currents and display the result. The touch current test is carried out by connecting the PAT to the appliance and the test probe to any exposed metal parts. If there is fault with the insulation, some of the current flowing in the live conductor will return to the supply via the test probe. The PAT will measure any touch current returning via the probe and display the result. The flash or dielectric strength test is carried out by applying a high voltage, typically 1500 volts AC, to both the live conductors of the appliance. If there is any breakdown in the insulation, the PAT will measure the current flowing through the insulation to protective earth. A test probe is required when testing a Class 2 appliance. The probe is applied to any exposed metal parts. If there is any breakdown in the insulation, the PAT will measure the current returning via the test probe. An RCD is tested by connecting it to the main supply and using the tester to generate a fault current equal to the rated current of the RCD. As the animation shows, the fault current will trip the RCD and the tester measures the trip time. For more information about PAT testing, please refer to the Seaward Guide booklet or visit our website.
Testing power cords. Welcome to this First Stop Safety video. This video module outlines the process of testing power cords using a PAT tester. We'll cover the basics of this test and then test a variety of power cords, including mains extension leads. Basics of a power cord test. When testing power cords, we carry out the basic Class 1 tests of earth continuity and insulation resistance. In addition, when testing power cords, it is important to ensure that the wiring of the cable is correct. This means checking that the live and neutral wires are wired correctly. This test is usually called the polarity test. Testing an IEC lead. The power cords used for PCs are commonly known as IEC leads. Most modern PAT testers have a handy IEC lead test facility. All you have to do here is plug both ends of the lead into the tester and test earth continuity, insulation resistance and polarity. The polarity test checks the lead is wired correctly. This can only be done if you have both sides of the power cord. Testing a standard mains extension lead. If a PAT tester has an IEC test facility, then this can be easily adapted to carry out a mains extension lead test as well. All you need to do is connect the short IEC lead to the socket of the mains extension back into the PAT tester as shown. It's important to test all the sockets on a multi-way extension lead in case one of them has a poor earth connection. Testing long extension leads. It is very common to come across 10 metre and 20 metre extension leads. When these are tested on a PAT tester, they will normally fail the earth continuity test due to their length. However, an allowance can be made for the length by increasing the pass limit. On this tester, the Seaward, a 10 metre extension lead will fail the earth continuity test as shown here. There is no way of continuing with the PAT testing. The BAT-PAT tester has a number of lead test options. On the standard setting, its limit is 0.25 ohms and it will pass extension leads up to 10 meters. Press the long lead button once and the limit is increased to accommodate leads up to 25 meters. Press the long lead button twice and the limit is increased to accommodate leads up to 40 meters. Testing surge-protected extension leads. Some appliances have built-in surge protection to provide immunity from damage due to voltage surges on the power lines. For example, many extension leads have surge protection built in. When surge-protected appliances are tested normally, they will fail the insulation resistance test due to the test voltage of 500 volts that is used. This can be seen on this PAT tester, the Seaward. When this happens, the user is allowed to either make a note about the appliance being surge protected and pass it, or retest with a 250 volt test voltage if one is available on the PAT tester. For example, this is an option on this tester, the Q-Tech, shown here. With the BAT-PAT, this is not a problem, as it automatically uses 360 volts for the insulation resistance test and will pass surge-protected appliances. Testing extension leads with RCDs. RCD stands for Residual Current Devices. These devices are primarily used to protect you from an electrical shock. Extension leads with RCDs fitted are Class 1 appliances and not extension leads. This is because without mains power, there is no through connection to the mains socket. These need to be tested for earth continuity and insulation resistance. No polarity tests are required here. The easiest way to get an earth connection is by using a plug adapter as shown here. Testing 110 volt extension leads. 110 volt extension leads are often used on construction sites. In order to test this, you'll need a PAT tester with a 110 volt socket. Alternatively, you can use an adapter like the one shown here with a normal PAT tester. You'll also need this socket adapter to connect the 110 volt extension socket back to the PAT tester. Using the two adapters, both ends of the 110 volts can be plugged into the PAT tester and the earth continuity, insulation resistance and polarity test can be carried out. Testing a cloverleaf laptop power cord. When testing this type of power cord, an adapter is required to allow it to be connected to the PAT tester. In summary, it is important to have a suitable PAT tester to test the variety of power cords that are out there. There are adapters available to suit different types of power cords. Testing microwave ovens. Welcome to this First Stop Safety video. This video module will give you guidelines on how to check that microwave ovens are operating safely. We'll look at what can cause microwaves to leak and how a properly calibrated leakage tester can be used to check for this. We'll also show how to check that used microwave ovens are working correctly before they are resold. PAT testing microwave ovens. Microwave ovens are electrical appliances and have to be PAT tested as normal. They are always of Class 1 construction, and it is quite easy to get an earth connection at the rear of the appliance. Danger due to microwaves. Microwave ovens use high-frequency electromagnetic waves to cook the food. In a properly designed and constructed oven, these high-energy waves are contained entirely within the cooking area. However, if these waves were to leak out, they can result in serious burns to the user. Levels of radiation above 5 milliwatts per square centimetre are considered harmful. What can cause microwaves to leak? Microwave ovens are designed to keep all the energy within the cooking area with negligible leakage. However, damage to the microwave, such as broken door hinges, door catches, damaged or missing door seals, or damage to the glass door can result in excessive leakage. Microwave leakage checker. Devices such as the one shown here can be used for checking the level of leakage from microwave ovens. It is very important to ensure that the leakage checkers have been properly calibrated before they are used. This leakage checker has an array of LEDs to display the level of leakage. It also has a spacer built in to make sure it is the correct distance from the body of the microwave when the measurement is being taken. When taking measurements with this leakage checker, it is important to align it both horizontally and vertically to check for maximum leakage. Checking for leakage. To check a microwave oven for leakage, it needs to be working. A standard test will take about a minute. The easiest way to do this is to put a large mug of water in the microwave oven and start it cooking at full power for 1 minute. Use the microwave leakage checker as shown here to scan the front glass and the door seals to check for leakage. Remember to use the checker in different orientations while looking for the highest leakage. If the result goes into the red at any time, the oven will have to be failed. If it is always in the green, then everything is safe. If it is always in the orange, then while this is not a fail, it is a cause for concern, and you should consider replacing the microwave at the earliest opportunity. Please note that the antenna in the leakage checker has to be at a specific distance from the microwave. Never hold the leakage checker like this, as it could give a high reading. Remember to check that the safety interlock works. This is verification that when the microwave is working and the door is opened, the waves are switched off. Reasons for testing microwave heating power. Anyone selling a used microwave oven is strongly recommended to check the heating power of microwave ovens. Many cooking recipes specify cooking times based on microwave power. If this is not being achieved in use, then there is a risk of undercooking food with the resulting risk of food poisoning. Microwaves can lose power for many reasons. For example, the microwave source can deteriorate with time, or internal connections can work loose. Build-up of food on critical parts can also reduce the cooking power. Carrying out a heating power test. We will need a plastic measuring jug and a thermometer for this. Fill the jug with about 300 ml of water and note the temperature. Heat this in the microwave oven at full power for a whole minute. Stir the water and note the final temperature. The volume of water, the temperature rise, and the heating time is used in this equation to work out the heating power of the microwave. If this is significantly different from the manufacturer's specification, then the microwave should not be sold. Microwave power, in watts, equals 4.2 times the volume of water in milliliters, times the temperature rise, divided by the time in seconds. In summary, all microwaves have to be tested for leakage with a suitably calibrated checker. A check of the safety interlock is also necessary. Used microwaves need to pass a heating power test before they are made available for sale.